Hello everyone, welcome back to Spectrum classes. Here in this video, we are going to discuss how this KMnO4 behaves in acid, base and neutral medium first. Secondly, we are going to check the change in oxidation state of KMnO4 in acid, base and neutral medium, which is very important from the IIT JEE and from NEET point of view. So this is very important. Secondly, we are also going to discuss the normality of KMnO4, how we are going to calculate that in different mediums and how whether it is same in all the mediums or it is changed. So if it is changed, then why it is changed. So we are going to have the answers of such questions in this particular video. So this video is very important for the class 12th students. Right. So let's start with the video. And first we are going to discuss the behavior of KMnO4 in acid medium. In acidic medium, KMnO4, the acidic medium is created by adding the H2SO4. Since H2SO4 reacts with KMnO4, but instead of this H2SO4, we are not taking HNO3 or HCl because HNO3 itself acts as oxidizing agent, so that will not be used here in this equation. And HCl reacts with this KMnO4 differently, so that is also not used to produce the acidic medium for KMnO4. So the only option which we have here is H2SO4 to produce the acidic medium for this KMnO4 out of three mineral acid, that is H2SO4, HCl and HNO3. So we are just having H2SO4 here. Right, so here KMnO4 on reaction with H2SO4, that is in acidic medium, we get the products K2SO4 plus 2MnSO4 plus 3H2O plus 5 this oxygen, which is written in the square brackets. This is the symbolization of nascent oxygen which is produced during the reaction. And this nascent oxygen behaves like an oxidizing agent further for the another reactant, like as we did in the titration of oxalic acid versus KMnO4. So this nascent oxygen oxidize oxalic acid, right? So this is how this KMnO4 behaves as a strong oxidizing agent. Now we are going to check the behavior of KMnO4 in basic medium. So in basic medium, this KMnO4 reacts with KOH. So here in the basic medium, this KMnO4 produces K2MnO4 plus H2O plus this nascent oxygen. In the neutral medium, this KMnO4 on reaction with H2O water molecule, water is treated as neutral. Right, so we are going to react this KMnO4 in water medium, then we get 2 KOH plus MnO2 plus 3 nascent oxygen. And one more thing which I bring to your notice, you have seen your burates or the measuring flask in which you have prepared the KMnO4 solution in H2O, you have seen later on that becomes brownish color after washing also. So that brown color is just because of this MnO, right? So this is the behavior of KMnO4 in acid, base and neutral medium. Now we are going to calculate the change in oxidation state of KMnO4 in Mn in acidic medium. Now the question comes, why we are going to check the oxidation state of Mn only. So here, since Mn is a central metal, so we are going to check the oxidation states generally for the central metal atoms. So here for Mn, we are going to calculate the oxidation state. So how we are going to calculate that? Here we are having this potassium, and potassium is having +1 oxidation state. Suppose we are having X oxidation state for this Mn. So I placed X over here, plus here we are having this subscript 4, so 4 times O, so 4 multiplied by O, and O oxidation state for oxygen is -2. So on solving this equation, we are getting this. Now one more question which comes here, why this 0? So this 0 means this molecule which we are going to consider here is neutral molecule. If it is neutral, we are placing 0 here. If it is charged, whether it is plus or minus, so the number of charges which we are having there, we place that here. Right, so on solving this equation, we are getting x is equal to plus 7. So this x is equal to plus 7 means manganese is having plus 7 oxidation state here in this equation for Mn as KMnO4. Now on the product side or on the right hand side, we are going to calculate the oxidation state for Mn. So here how we are going to calculate this? Here we are having MnSO4 first. So SO4 is the group of atoms, and this group of atoms is having, that is sulfate ion. So sulfate ion is having -2 oxidation state. So here we are having -2 for this SO4. So this is not considered as subscripts. This is collective, right? SO4 is one group of atoms. So it's a group. So we are consider total SO4 minus minus. So for SO4 we are having -2. Since this molecule is again neutral, so we are placing 0 on the right hand side. So here we suppose that Mn has X oxidation state. So X plus -2 is equal to 0. And on solving we are getting X is equal to +2. So the oxidation state for Mn in MnSO4 is +2. So what you have seen here, for KMnO4 we are having +7 oxidation state, and for MnSO4 or on the product side we are having +2 oxidation state. So how we can get this +7 to +2? If we add -5 to this side or left hand side, then only we can get +2, right? This we can consider this as an equation. So +7 minus 5 will gives you +2. So from where that -5 will comes? So that -5 will comes, say, by 5 electrons. So 1 electron is having -1 charge. So 5 into -1 will gives you -5. So here 5 electrons are involved. In this manner, you can easily calculate how many electrons are involved in a given particular equation. And the change in oxidation state will be considered as n factor while we are calculating the equivalent weight that we are going to discuss on the later slides. And now we are coming to the basic medium. In the basic medium, we are having this KMnO4 on reaction with KOH, it produces K2MnO4. So what is the change in oxidation state in the basic medium? Now we are again calculating this oxidation state for Mn. So that is same as we have done previously. In KMnO4, Mn is having +7 oxidation state, and on the product side we are going to calculate. So here what you have seen here is K2. So 2 is subscript. So 2 into +1 for potassium. Mn is having X oxidation state plus, here we are again having oxygen with 4 subscripts. So 4 times oxygen. Oxygen is having -2. And since this molecule is neutral, so here I have written 0. You may also have a question, what about this 2, which is a coefficient of this, right? So this 2 is not considered when we are calculating the oxidation, right? So this, you can leave these coefficients, you can only take the molecule. So when we are solving this equation, this X will be is equal to +6. So oxidation state in the basic medium for Mn changes +7 to +6. Is how we are going to have this +6 from +7. So by adding -1 to this +7. So 1 electron is needed for this KMnO4 to convert K to MnO4. So in this equation, 1 electron is involved. And this change in oxidation state in basic medium is 1, 7 to 6. So 1. So n factor is 1 here, which will be considered to calculate the equivalent weight in the basic medium that we are going to discuss in the next slide. Now coming to the neutral medium. So in the neutral medium, we are having 2KMnO4 plus H2O, it gives you 2KOH plus MnO2 plus 3 nascent oxygen, right? So we have previously calculated this oxidation state of this Mn in KMnO4, that is plus 7, and here for MnO2 we are calculating this. So Mn is having X oxidation state, plus we are having this 2 as a subscript, so 2 times oxygen is having minus 2, and since this molecule is neutral, so equal to 0, and on solving this X becomes 4. So we are having change in oxidation state of Mn in neutral medium is plus 7 to plus 4. So how we are having this plus 4 out of this plus 7? So by adding minus 3. And how we are going to add this minus 3? So electron is having minus 1, and if we multiply minus 1 with 3, then we are having minus 3. So 7 plus minus 3, we will get 4. So in this equation, 3 electrons are involved. So the n factor, that is change in oxidation state, is 3. What we have calculated in our previous slides, oxidation state of manganese in acid medium, basic medium, and in neutral medium. Now the equivalent weight, right? So how we are going to calculate the equivalent weight? So equivalent weight is equal to molecular weight divided by n factor. So as I told you earlier, what is n factor? N factor is change in oxidation. So this formula can be written as equivalent weight is equal to molecular weight divided by change in oxidation state per mole. So this is important, per mole, right? So here the change in oxidation state is 5, that is 5 electrons are involved in this reaction, and here change in oxidation state is 1, and in the neutral medium the change in oxidation state is 3. So if we are going to calculate the equivalent weight of KMnO4 in acid medium, then molecular weight, that is 158 divided by 5. If we are going to calculate the equivalent weight of KMnO4 in basic medium, that means 158, that is the molecular weight of KMnO4 divided by 1. So same is there, right? So here in this case, normality is equal to molarity. In the neutral medium, we are having change in oxidation state is 3. So molecular weight, that is 158 divided by 3. So this is how we can calculate the equivalent weight. All such things I have tabulated. So this table is very important for your exam point of view. What is the medium KMnO4, and what is the reagent for the KMnO4, and what is the product which is formed for this Mn, number of electrons involved in the reaction, equivalent weight, how we are going to calculate the equivalent is 3 different mediums. And now we are coming to the question how we are going to calculate the normality of KMnO4 solution in different mediums. So here I am giving you the simplest formula to calculate the normality of a given compound. Right, so here what you are having weight, or this is given weight. If weight is given, you can calculate the normality. If normality you want to prepare solution, you can easily calculate the weight. If you want to prepare 0.1 normal solution of KMnO4, then what weight I have to weigh, so that you can calculate by this formula. Here n is the normality which you have decided. E is the equivalent weight which we can take from this table for different mediums. Means for different mediums, that is acid, base and neutral, equivalent weight is changed. So in case of acid, base or neutral medium, normality will be different. So that is important here. Now coming to the volume. So if volume is given in ml, then you have to change it into liters. So ml divided by 1000, you will get volume in liters. If it is given in liters already, then no need to convert, right? So then in that case, formula will be weight is equal to NEVV in liters. Fine. So this is how you can prepare the solution. Now I am showing you the solution of KMnO4 in the lab activity. So one Important thing for your competitive point of view, this question or sometimes objective question is asked from this table. So how you are going to memorize this? So suppose KMnO4 is a person and it is having number a vehicle and the number plate of that vehicle is like this. So how you are memorize? So here A stands for acid in which change in oxidation state of Mn is 5. B is the base in which change in oxidation state 1. And N is the neutral medium in which change in oxidation state of Mn is 3. So this is how you can memorize this, and if you get any of the objective question related to, you can easily do that with concept. So here I am showing you the reaction of KMnO4 versus oxalic acid, in which KMnO4 works as an oxidizing agent and itself get reduced by producing the nascent oxygen, whereas this nascent oxygen reacts with the oxalic acid and oxalic acid converts to CO2 gas and get oxidized. Here I am preparing the KMnO4 solution. I have taken some weight of KMnO4. Now I dissolve it thoroughly. Make up to 100 ml. This is 100 ml flask. Here you can see the lower meniscus, right? So this is 100 ml. Now I transfer it to burette. I'll just rinse it first. After rinsing the burette, here I'll fill this burette. Here you can see this is more than 0, but that is purposefully done because we need to fill this nozzle. So here you can read the lower meniscus. This is the initial reading. So initial reading of the burette is 0. Now we will take the oxalic acid. Acid is 0.2 molar. So I will take the 20 ml of oxalic acid. I use the measuring cylinder just to show you. I do not use pipettes, but you can use pipettes here. That is more accurate actually. So now I am rinsing this conical flask with oxalic acid, which I am going to transfer to this conical flask. So this is 20 ml, and to this 20 ml, 1 ml of 4 normal H2SO4. So the question, why we are adding this to the oxalic acid, and now I am going to heat this solution. So this is heating mantle. I set the temperature up. Here you can see that it is warmed up. Now we will start the titration. Indicator we are using in this titration, this is redox titration. There are 3 different type of indicators used in the redox titration, and one of them is self indicator. So here KMnO4 works as a self indicator. So that is why we are not using any additional indicator in this reaction, and at the end point purple color of the KMnO4 appears. That is how we come to know that end point reaches. Or initially what you have seen here, I'll just explain. In the conical flask we are having oxalic acid. That is, oxalic acid is present in the conical flask. The color of this KMnO4 disappears because MnSO4 is of no color. The titration is going on. Still oxalic acid is present inside this. The disappearance of KMnO4 color suggests that, and at the end point, since all the oxidizing agent, that is oxalic acid, is finished, and the extra drop of KMnO4 will not get reduced to MnSO4, so we will get the purple color of KMnO4. So here you can see the purple color of KMnO4. It means all the oxalic acid reacts with the KMnO4. Now I will show you the reactions, how this reaction proceeds. So here I will show you the reactions. This is KMnO4, H2SO4. The reaction proceeds in the molecular form. Here is the nascent oxygen. Here is the oxalic acid. This nascent oxygen reacts with the oxalic acid and it oxidizes the oxalic acid to carbon dioxide. Here I'll just explain you why we have multiplied this 5. Since here 5 oxygen is produced. In the earlier slide, I have told you that removal of oxygen. So here removal of oxygen KMnO4. So here removal of oxygen from this species. So this species get reduced. So here 5 oxygen, nascent oxygen is produced. This behaves as an oxidizing agent. And this oxygen on reaction with this oxalic acid, it oxidizes this oxalic acid to carbon dioxide and produces carbon dioxide plus water, right? So why we have multiplied this by 5? So since 5 oxygen is produced in the previous equation, so here we have to multiply this equation just to balance these two equations by 5. So this is 5 times oxalic acid. This 5 nascent oxygen will cancel out, K2SO4, 2MnSO4. Here is 5 3 ja 15 plus 3 18 H2O plus 5 2 ja 10 CO2. So that is the molecular equation. Now ionic equation. So from this KMnO4 we will have MnO4. From this H2SO4 we will have this 8H plus and 5 electrons are involved in this reaction, right? Here is the oxalic acid. So from oxalic acid 2 electrons are evolved. So here it is important that in this MnO4 reaction 5 electrons are consumed or gained by the Mn, and in the oxalic acid here 2 electrons are evolved. Here 2 electrons are evolved and here 5 electrons are consumed. So how this is not possible? We have to balance the equation in terms of electrons. So here this equation is multiplied by 2 and this equation is multiplied by 5. So here we are having 10 electrons and here again we are having 10 electrons. So in this way we have to multiply these equations just to balance the number of electrons. This is 16H plus 5 COO minus this 2 Mn2 plus 8 H2O, 10 CO2 and 10 electrons will be cancelled out by these 10 electrons, right? This is how the reaction is. So here we are using KMnO4 as well as oxalic acid. So KMnO4 here in this titration will get reduced and works as an oxidizing agent. So it itself gets reduced and works as an oxidizing agent. Whereas oxalic acid in this titration will get oxidized to carbon dioxide. Since it loses the electron, it itself get oxidized and works as reducing agent. Fine. So this is the summary of the redox reactions. So I hope you find this video helpful and interesting also. If you find this, please like, share and subscribe. Thank you all. Thanks for watching.